Hi friends, welcome to my channel JK Competitions. This is your Ajay Minar. Today we are going to discuss an important topic, that is grade 10 electricity. Grade 10 electricity. This chapter is very important as per the examination point of view, board point of view. In board class or board exam, this chapter weightage is about 10 to 12 marks, particularly numericals from this chapter are very important to practice. So these numericals may be in the form of MCQs or in the form of descriptive. But anyways, this weightage is about 10 to 12 marks. So it's very essential for everybody to focus more on these numericals. Okay, without wasting our time, let us start today's class. So class 10 electricity, which we are going to discuss now. In that numerical part we are going to discuss. For the first question today, calculate the number of electrons. Calculate the number of electrons constituting 1 coulomb of charge. 1 coulomb of charge. See, my dear friends or my dear students, we have to calculate number of electrons present in 1 coulomb of charge. Now first of let us see what is a charge. Charge, as we know already, that it is an intrinsic property of a material. It is a negative charge and a positive charge, that we know everybody. So that charge is present in every material, irrespective of whether it is conductor or insulator, whatever it is, right? So this charge is measured in terms of coulombs. Coulomb is the SI unit of charge. Coulomb is the SI unit of charge. This is proposed by, this is named after Charles D. Coulomb. Charles D. Coulomb, and he just he proposed a Coulomb's law. According to this, this law explains the electrostatic force between two charges. So, named after him, on behalf of him, or honoring him, SI unit is introduced by scientific word to measure the electric charge. Here, with respect to this one, we are discussing, or we are trying to coordinate with the charge, electric charge. Now, in 1 coulomb is SI unit of charge to be measured. We know that charge is an intrinsic property of a material. That means electrons, they possess charge. Now even protons also possess positive charge. Now here each electron which possess a certain amount of charge. Now 1 coulomb means it's not single electron, it's plenty of electrons. Practically to say, it's almost to 6.24 quintillion electrons. The amount of charge present on 6.24 quintillion electrons is equal to 1 coulomb. Basically, practically, coulomb is a very big unit to measure electric charge. Now, from this numerical, or from this problem, we will try to find out how many electrons are present in 1 coulomb of charge. To find out this one, first of all, we should know the charge on each electron. Charge on 1 electron, that we should know. Charge on 1 electron. See friends, this is for 2 marks question. Charge on 1 electron, it is minus 1.6 into 10 power minus 19 coulombs. Charge on 1 electron is equal to minus 1.6 into 10 power minus 19 coulombs. Now, how many electrons we have? We have 1 coulomb of electrons. Therefore, 1 coulomb of electrons contains, or 1 coulomb of charge contains how many electrons? This is our question. Charge on 1 electron is equal to minus 1.6 into 10 power minus 19 coulombs, or 1.6 into minus 19 coulombs, and 1 coulomb of charge is equal to how many electrons? Now let us use unitary method. Unitary method, cross multiplication, we can use it here. One electron charges 1.6 into 10 power minus 19 coulombs. Now 1 coulomb of charge is equal to 1 by 1.6 into 10 power minus 19 coulombs. 1 by 1.6 into 10 power minus 19 coulombs. So here you will get 1 by 1.6, you will get approximately 0.624. 0.624 approximately you will get it. Now let's bring this denominator to the numerator place, that is 10 power 19. 10 power 19. From this, if you just shift this decimal here to the right side, then that is 6.24 into, then power will be reduced by 1, that is 10 power 18 electrons are present in 1 coulomb of charge. 1 coulomb of charge is equal to the amount of charge present on 6.24 into 10 power 18 electrons. This is going to be your answer. This is how we have to find out the number of electrons in 1 coulomb of charge, right? Now let us see our next question, next numerical for us. How much energy is given to each coulomb of charge passing through a 6-volt battery? I'll read the question again. How much energy is given to each coulomb of charge passing through a 6-volt battery? Now here we have to calculate energy, right? We have to calculate energy, right? Here we have, if you just draw a diagram based on the given data, we have a battery here which is 6-volt battery, through which some charge is being moved. Some charge is being moved in the circuit, right, through 6-volt battery. Now how much external energy, or here the energy in the sense potential difference or voltage, how much voltage is required, how much work to be done, external force, how much work to be done to push 1 coulomb of charge through a 6-volt battery? That is the question that we have to find out. Here if you write the given data, what is the given data? Let us see. Here given data, charge is given, that is 1 coulomb of charge. Now voltage also given, that is called potential difference, that is 6 volt. Now we have to calculate energy to be calculated. Here energy is nothing but work done to be calculated here. Now here we have to understand one thing here. The energy given to each coulomb of charge is equal to the amount of work done. So we have to understand in this way. The energy which is given to push 1 coulomb of electric charge through a circuit or battery is equal to amount of work done. We know the amount of work done formula. Work done is equal to potential voltage into voltage or potential difference into charge. Work done is equal to voltage into charge. Since we know that voltage is equal to work done by charge, From this formula we got this one. Voltage or potential difference is equal to work done by charge. From this, if you rewrite this formula, work done is equal to W is equal to voltage into charge, V into Q. Work done is equal to V into Q. Now we know here we know that is 6 volt. 6 volt we have V, and Q we have charge, it is 1 coulomb, that is 1. 6 into 1, 6. Now we know that what is the SI unit here? What is the SI unit of work done here? It is joule. It is joule. So this is going to be your answer. That means 6 joules of work done or 6 joules of energy is required to push 1 coulomb of electric charge through 6 volt battery. 6 volt battery. Right? So here SI units are very essential, my dear friends. Here work done SI unit is joules, and potential difference or voltage is volt, and this is a charge, electric charge, it is expressed in terms of coulombs, right? So here according to this formula, voltage formula, that is V equal to W by Q, and take this V out, V is W out, W is equal to V into Q. We know V it is 6 volts, Q it is 1 coulomb, 6 into 1, 6 joules. So work done, the energy is required to push 1 coulomb of charge through 6 volt battery is 6 joules of energy required. This is, my friends, thank you very much, and we will discuss more numericals in upcoming video. Thank you, thanks for watching. If you like this video, please subscribe it, share it. Thank you for watching.